So now we're going to go over another way to categorize variables besides levels of interest, and that way is levels of measurement. And here's a definition for you. A categorical variable is a variable that is measured in distinct categories, and this is in contrast to a scale variable, which is a variable that has innate numerical values to it. Okay, categorical versus numerical. Now we're going to go over some examples. You might want to try to do this on your own before I tell you the answer. So maybe you pause here and try to put these variables that are in white into the correct colored boxes here, either categorical or scale. Okay, and here we go. So here we have age and years. So this has an innate numerical value to them. So, you know, it could be 10 years old, it could be 20 years old, or whatever. So this has some innate numbers to them. So we're going to put that in the scale box. Age and ranges. We have two of the same constructs, right? Both are age, but one is in years and the other one's in ranges. So maybe the ranges are below 18, and then you have 18 to 25, maybe 26 to 30, 31 to 40, I don't know. However you want to cut them up and so on and so forth. So these would be in distinct categories instead of by year, and so there's not really this innate number to the ranges anymore because we put them in categories. So this would be a categorical variable. So you should see that it doesn't matter really what the construct is, it's really about how we measure that construct, how we operationalize that construct. That tells us what level of measurement it is. So just keep that in mind. The same construct can have two different operationalization, and that means at one point, one variable, the same construct can be categorical, and then the next time we can measure it as a scale variable. Okay, now we have flavors, and so flavors would be categorical, right? You could have different ice cream flavors, vanilla, chocolate, strawberry, whatever your favorite is, and so that would be categorical. Now we have gender, and we're going to label one as female and two as male. So you're like, oh, there's numbers, so that has to be scale, but you'd be wrong. So gender doesn't have any innate numbers to it. You know, I just made up these numbers, one for female and two for male. There's no reason to say females are 1 and males are 2 unless you think females are the superior sex for some reason. But other than that, you really shouldn't be ranking them. And so these numbers are just really made up. So it's still categories, we're just giving them numbers. And so it's still a categorical variable. So you might give categorical variables numbers sometimes just to make the coding and the typing into the computer a little bit easier for you. But that doesn't mean you change the level of measurement by doing that. It's still a categorical variable, even if you say 1 is female and 2 is male. Now we have number of children, and anytime you have a count variable like this, you're counting something, you're counting the number of children, that's going to be a scale variable. And lastly, we have time in seconds, and that's going to be also a scale variable because time has this innate numbers to it. So for people who can't get enough of statistics, here's a little note for you. If you would like to know the difference between nominal and ordinal variables and between interval and ratio variables, you should see the handout. So I kind of skipped over this part, but nominal and ordinal variables are categorical variables, and interval and ratio variables are scale variables. Now, I skipped over it because 1, you don't really need to know it for the rest of the class, and 2, it's sometimes a little difficult for students to get the difference between these 4. But when I do it categorical and scale, it should be a little bit easier to grasp. But if you want to go the extra mile and learn all 4 of the categories, then go for it. So one last thing, I want to go over a little bit more about levels of measurement, and this is related to the categorical and scale thing, but it's not in the same categorization method, okay? So a discrete variable is something that is finite or countably infinite. So, for example, any categorical variable is discrete. We can count it. We can say there's only 4 flavors of ice cream that we're going to measure today. And what I mean by countably infinite is that they take on discrete numbers, but those numbers might go on forever. So, for example, the number of children. Somewhere you're probably going to end it, but, hypothetically, I guess someone can have an infinite amount of children. So, but we can count these numbers of children, and we're going 0, 1, 2, 3, 4, 5, 6, 7, and so on. We don't have half a child or 3/4 of a child. We don't have anything in between, and that's what it means by discrete. And then we have what's called continuous variables, and those are variables that have infinite amounts of values that it can take on. So when you're measuring time, for example, you could be like, it's a 1.2234567 seconds or something like that. And so there's an infinite amount of values it can take on because you can be really, really precise with time if you want to. So here we have a roll of the dice, and you can have a discrete number of values on the roll of dice. So you can have, if you have 2, you can have 2, 3, 4, and so on. So this would be discrete. And then if you're measuring something, you can get really specific if you wanted to, for your little OCD or something. And so that would be continuous.